Hello guys, welcome back to my channel, Boy. In this video, I will be talking about excess air calculation in UniSim design. So we will use the previous example on combustion simulation to calculate the excess air in the current condition. Okay, so now I will choose the Gibbs reactor model for this condition, and let us take a look to the formula first. Yeah. So here I'm taking from Learn Chemi YouTube channel. So percent excess air we can calculate by the mole of air fed to the combustion reaction uh, minus the mole of air theoretically divided by air theoretical and times with 100%. Okay, so in default, we don't have this kind of calculation and this kind of variable in UniSim design, but of course we has the flexibility. Uh, we of course we have the flexibility to calculate anything as long we know what is the formula for that. Okay, so let's start. I will start with a spreadsheet here. I will name it as excess air calculation. Okay, now the first thing is I will make think 3 rows. The first row is the component, and then the second one is mole of component at fit, or four I think. And the third one is theoretical. Yeah, okay, three is enough. Okay, this one is C1, C2, C3, IC4, NC4, IC5, NC5, NC6, NC7, and C8. Okay, this example only until NC8. Okay, so right now, first of all, how to calculate mole air theoretical is by knowing how many hydrocarbon do we have in our feed. Okay, uh, because later we could calculate the theoretical air by the coefficient of the stoichiometry. Okay, so let's take a look from here. Go to composition and change the basis into mole flow. Yeah, like this. Okay, now we will import every variables to this Excel. Okay, done. Now we already have the flow of each hydrocarbon at our feed. And to get our theoretical air, we just use the correlation from the reaction stoichiometry. So for example, for C1, the the theoretical mole of O2 is 2 times then the mole of C1. So we can write as B2 times 2. Okay, for C2, it's 3.5 times B3. And then for C3, 5 times. Yeah, we'll do all the way. Okay, so now we have calculated the theoretical air that needs to fully burn the hydrocarbon. Okay, so the next thing is we will sum all of this. Yeah, total theoretical air. Put sum. Okay, we got one variable, total theoretical air, and then we will export or import our current. Oh, sorry, this one is not theoretical air. Yeah? Okay, this one is theoretical O2. Okay, beware of it. Okay, if we want to calculate theoretical air, then we need to have another formula, 100 divided by 21, the concentration of O2 times theoretical O2. Okay, now we can copy paste. Okay. Okay, this one is theoretical O2 and this one is total theoretical air. Okay, now we already got one of the parameter, and the other parameter is the air at feed. Yeah, the current air. Okay, molar flow of air. Okay, we could get from here 9,000. Okay, so from here we could know that actually our current flow of air is less than the theoretical air, which may lead to unburned hydrocarbon. Okay, so now let's calculate the percent excess air. Okay, the formula is of air feed minus theoretical divided by theoretical. Okay, air feed minus theoretical divided by theoretical times 100%. See, you will get a negative value. Now we can manipulate this flow. So we will have a positive value of excess air. Okay. Now, if we want to target a certain excess air, it's very easy. We can use adjust. Yeah. Okay. I will use adjust block here. Okay. What variable that we will adjust? Yeah, the flow rate of air. Air must flow. Okay. The target variable is our spreadsheet excess air calculation. Excess air. For example, I wanted 8%. Okay. Then the adjust will manipulate this airflow. Yeah. So we will get the correct excess air. Yeah, we get 8% of excess air. Okay, so that's it for our video today. I hope it will be useful for you for your study or for your project. And if you like this video, don't forget to hit the subscribe, like, and share button. And see you at the next video. Bye bye.